We've defined these rational exponents, and based on these rational exponents, we can consider, for every rational number, a corresponding power function, f of x equals x to the power p over q, which we can think of as the composition of a radical function and a power function. We can use the composition to figure out the domain and range of these power functions. If p and q are both odd, that means we have an odd root and an odd power. Those are both 1 to 1. They both have as their domain and range all real numbers. So if p and q are both odd, we have a 1 to 1 function whose domain and range are both all real numbers. Now, if p is even, so the numerator in our fraction, the power function in our composition, is even. We're taking an odd root, so the domain is still all real numbers. But the range, when we take an even power, consists of only positive numbers or 0. So the range is the set of x such that x is greater than or equal to 0. Or in interval notation, we can write 0 to infinity. If we're taking an even power, that means we can only get a positive output. Now, if we're taking an even root, if q is an even number, well, for an even root, we can only take positive input. Right, so the domain consists of the numbers greater than or equal to 0. But even roots also have positive output. And then we're taking the powers of positive numbers. And so the range also consists of numbers greater than or equal to 0. So if the numerator's even, the domain is still all real numbers, the range is only positive numbers. If the denominator's even, the range and domain are only positive numbers. And we can also think about negative exponent power functions while we're thinking about this. If p is a negative integer, the only difference is that 0 is not included in the domain and range. And notice we had a case where p and q are both odd, where p is even, where q is even. We didn't consider the case where they're both even, because when we think about the power function, we think about writing our rational exponent in lowest terms. If p and q are both even, then p and q have a common factor of 2. So our rational exponent wouldn't be in lowest terms. We don't need to consider a case where p and q are both even. So let's see some power functions and find their domain and range. So here we have an even numerator, an odd denominator, and 2/3 is positive. So the odd denominator tells us that the domain is all real numbers. The even numerator tells us that the range consists of only positive numbers. So 0 to infinity in interval notation. In this next example, g of x, we have an odd numerator and an odd denominator, and our exponent is positive. So the odd numerator and denominator mean that the domain and range will both be all real numbers. In this next example, my numerator is odd and my denominator is even. And again, my exponent is positive. And the even denominator tells me that my domain and range will both consist of positive numbers. Because hidden in this function is an even root. And finally, here we have an odd denominator, an even numerator, and my fraction is negative. So my odd denominator would make my domain all real numbers, except that my exponent is negative. So my domain consists of all real numbers except for 0. So if I desperately want interval notation, that's negative infinity to 0, union with 0 to infinity. My range, because my numerator is even, consists of non-negative numbers, but also not 0. Because again, my exponent is negative. So that's going to be the set of x such that x is strictly greater than 0. Or if we really want interval notation, 0 to infinity with 0 not included. So the negative exponent means the domain and range do not include 0.